Hello all, today we are covering 1.4, solving equations. So this is a review from Algebra 1. We're first going to start with solving two-step equations. We need to solve using reverse order of operations. Also, it's good to note that if I see subtraction, I'm going to add. If I see addition, I'm going to subtract. If I see multiplication, I'll divide. If I see division, I will multiply. So we do the opposite operation of what we see. So I see addition on part A. So I'm going to go ahead and subtract on both sides. We want to keep it balanced. What I do to one side, I do to the other. Negative 12 plus a negative 4 is negative 16. Go ahead and divide, and we got x equals negative 8. Part B, similar. I see subtraction, so I'm going to add on both sides. So I have 3x equals 18. I see multiplication here. When a variable and a number are right side by side, that's multiplication, so I will need to divide by 3 on both sides. So x will equal 6. Now we're going to solve some more equations. Once again, I see addition, so I'm going to go ahead and subtract 8 on both sides. And I get 4/3 x equals 12. Now we can't divide by a fraction, but we can multiply both sides by the reciprocal. And these cancel out to 1, so we now have x equals 36 over 4, or x equals 9. If you prefer to not multiply across to start and go ahead and reduce, instead, we will still get the solution x equals 9. This problem, there's a couple ways to do it. You can keep everything in fractions, find common denominators, and go from there. Or we have something that I like to call the magical way, where we make everything a common denominator. So the common denominator for the whole thing would be 15. And I know 1 with a denominator 15 has to be 15 over 15. I have to multiply this by 5, so both are multiplied by 5. So 5/15 is the same as 1/3. And I must multiply this by 3, so 3/15 is the same as 1/5. Now once all the denominators are the same, I go ahead and I multiply the whole equation by 15. That will cancel out all of our denominators. So I'm left with 3x plus 5 equals 15. Now solve it like we did our first couple. Subtract 5 on both sides. So x is going to equal 10 over 3. If you had kept your problem in fractions the whole time, you'll get the same answer. Right, these next two, we have to get our x's, our variable, on the same side and our numbers on the same side. So I'm going to do my best to make sure everything stays positive. That's not always possible. Subtract 7x on both sides. Add 5 on both sides. So I have 18 equals 2x, or x equals 9. When I see parentheses that I can't reduce within, but have something multiplied on the outside, I know I need to distribute. So I go ahead and say negative 27 plus 6y equals 3y minus 9. Now it looks like C. I subtract 3y on both sides and add 27 on both sides. So I get 3y equals 18. Divide by 3 on both sides. Y will equal 6. Alrighty. E and F are a little different. We are going to go ahead and combine like terms. So I get 4 plus 3x on the left side equals 3x plus 5. Go ahead and try to solve for x. I would start with my x's this time though. I subtract 3 on both sides. And my x's go away, so I'm left with 4 equals 5. This is false. So, if I get a number equal to a number that's not itself, 4 can never be equal to 5. This means there is no solution to this problem. On the other hand, you'll see on the next one, we get 4x plus 5 when we simplify equals 4x plus 5 after combining like terms. Notice when we move things around, we end up getting that 0 equals 0. This does check out, so we know that there is an infinite amount of solutions. Any number you plug into this equation will be a solution. Alright, now we are going to rewrite the following equations for the indicated variable. So instead of solving for what y equals, we now have two variables, x and y, and we are going to solve for one of the variables. So we need to get y by itself for a. So I'm going to go ahead and subtract 9x on both sides. I now have negative 4y equals 7 minus 9x. And I go ahead and divide by negative 4 on both sides. So y equals 7 minus 9x over negative 4. Okay? Similar here, except this time we are solving for x instead of y. So we will subtract 5y on both sides. We have 3x equals 8 minus 5y. Divide by 3. And we have x equals 8 minus 5y divided by 3. Alright, this next one you'll notice we are solving for x, but we have x in both sections. So we can't subtract anything over and then divide. We can, however, pull an x out. So we can say x and then within parentheses 2 plus y equals 6. Now this works because we are doing reverse distribution. If we were to distribute this x back through, we'd have our original problem. So we can pull an x out because it's a common term. And then we can divide by what's in the whole parenthesis. So our solution is x equals 6 over 2 plus y. Similar for this one, but we're solving for y. Once again, pull a y out, and we are left with x plus 7 equals 13. divide the whole thing by x plus 7. And I am left with y equals 13 over x plus 7. All right, and then the last two are 2-word problems. So solve the following application problems. We have 2 less than 5 times a number is 8. So we have 5 times a number, our variable x, and 2 less than that equals 8. Then we just go ahead and solve for x. So we have 5x will equal 10, which means x equals 2. Alrighty. And lastly, Jack earns $7.50 per hour at his day job, but he is only allowed to work 30 hours per week. So if he makes $7.50, you can multiply that by 30 to figure out how much he makes in a week. His dad will pay him to do chores around the farm and work as many hours as he would like, but will only pay him $5 an hour. So we should add $5 per hour, I'll say x. If Jack wants to earn a total of $412.50 per week, how many hours should he work at the farm? So we are trying to find hours, which is our variable x for working at the farm. So go ahead and solve this. So 750 times 30 is 225 plus 5x equals 412.50. Go ahead and subtract. Oops, 5. We get 5x equals 187.50. Divide by 5. And x will equal 37.5 hours. So he could work a total of 67.5 hours per week to make $412.50. All right, that is lesson 1.4, solving equations.